Next up today, we're thinking about the practicals that we use to find a value for G by dropping things. And here is the low-tech version first. So let's say we're dropping by hand, say a tennis ball, and the displacement will be the distance that it falls. And we also measure the time using a stopwatch. So that will give us these values, and this is the G that we're trying to find. So we're assuming that there's no air resistance and that there are no other forces on the ball as it falls. So then you want the S equals ut plus a half at squared, but u is 0, so you get this. And if you only had one set of results, you would rearrange at that point, and then you could substitute and get value for G. But if you have done a range of values of S, which is much better, you can then plot a graph, and we have S on the y-axis, t squared on the x-axis, and this is a constant. So that means we've got y equals mx, and so the gradient is a half g there. Okay, but that's the low-tech version. Here is a more high-tech version that I think it's important that you have seen before. It used to be very common in schools, but I'm not 100% sure everyone will have seen it now. In this arrangement, you've got an electronic timer and an automatic release mechanism, and so you have much better precision than if you're measuring the time using a stopwatch. So how does it work? Well, in the beginning it's switched on here, so this is an electromagnet and the ball's stuck to it. And then what you do is you press a button down here and it simultaneously turns off the electromagnet, releases the ball, which releases the ball, and then also turns on the timer, starts the timer. When the ball hits the trapdoor and opens the trapdoor, that automatically stops the timer. So this will give you a time measurement correct to the nearest hundredth of a second, which is a big improvement over the low-tech version that we've just seen. It's not perfect, of course, and the thing you should know about this arrangement is that when you press start here and it turns off this circuit, you get residual magnetism in the electromagnet. In other words, this doesn't lose its magnetism straight away, and that means there's a small delay in the ball being dropped. And that, so if you've started the timer but you haven't quite dropped the ball yet, that means that the time measurements are going to be a little bit too big. And so if you look at our formula from before, if our time measurements are a little bit too big, that means our value for G is going to be a little bit too small. And so you can see in this question, this is what they were asking for there. Give a reason why your value would be less than 9.81. So if you see this arrangement, it's good, it's really good, but a potential problem is that residual magnetism when you press start.